Welcome to this video where I will demonstrate the functionality of my application iris-DataViz. This application leverages the functionality of Iris embedded Python and SQLAlchemy, and also it uses PyGWalker Python library for data analysis and data visualization. This is application interface. Um, Here we are selecting the namespace, then the schema, then the table, and then we can view the data and visualize the data. These are some of the features of the application. Uh, Basically, it's using the Tableau style drag and drop functionality. So it's a drag and drop visualization and plus other features. So the application, we can clone the repository and we can use the Docker. So application is already running. I just cloned the repository and I run this Docker Compose up to run the application. So the application is already imported some correlated data. In order to view the data, we just navigate to the management portal. So here I'm the SQL. So in the management portal SQL. So uh, let me log in. So in the table, so this is the table is data with schema and cars info table. So this is our data. So now we'll run the application to navigate the same data. So this is a Streamlit application running on the port 8051 on the local host. So this is application. So I mean, have to select the namespace, which is user and the schema, and then the table. So the application will retrieve the data from Iris. So this is the same data we have there, the same make model year. So make model year. But here we can also analyze the data. I mean, we can get some information, some insight of the data. We can apply the some filter, uh, and then we have this visualization tab. So here we can just visualize our data. So these are all the field list. These are the functionalities, and this is uh, x-axis and y-axis. So let's put the make to the x-axis and the year to y-axis, and we can put model uh, for the coloring. So here we can select different graph types. We can also select table plus other options. Uh, and there are also some other features. Here we can adjust it to just fit in the container. So this is our data. So there are other functionalities. We can also export this graph and export the CSV file as well, plus other some configuration. So basically, this is the interface, and this is the all this functionality. Even here, there is some option for coordinating system generic information. So these are all the functionality we have. We can put another tab for other visualization as well. Uh, so here we can also retrieve the data from the CSV. And the repository also contains some CSV files. In the data folder, we have this bike sharing and cars data. So we can also get the data. This is a bike sharing. So same thing we have this here the data. We have 17,379 records. and same the columns here and all this plus this same functionality we can apply here as well. So other way we can select the cars info. So this is the same data we have in iris as well. So we also have in the CSV file in this repository. So just have a look some of the code here, some important one. Mainly the we are getting this when we say from iris, we are selecting the namespace. So in order to select this namespace, we are using the object script. So the code is here. In the DC, we have this util class. So this class is getting this namespaces and returning back. And then in the Python code, app file, we are using import iris. This is one of the way to use embedded Python. So we are importing iris, and then this we are using here to populate the namespaces. So this we are getting the namespaces, and we are using split function and passing to our select. Once we have these namespaces, so then we have to use get the schema and then the table name. So this we are getting. There is another data is util function. This Python file. So we are initializing this. This is using SQLAlchemy to for the connection, and we are passing this information, the namespace also. We are getting there, and we are passing here. So this is a function to retrieve the schema. So we are getting all the schema from this information schema tables, and then we are getting the table name from the same table by passing the schema. And after that, we are using this function getDF to retrieve the data. So we are passing the table uh, along with the schema. We're using select asterisk, and also we are passing the top number of records. And then this we are using basically here. So this is a this here we are just getting this data. This is returning as a data frame, and then we are passing this to the Streamlit render function. So this is a function basically we are getting from this library PGWalker API Streamlit. So this is used to use this library in the Streamlit application. So we are passing this here, and then there is some specifications. We can also save some specifications, and then we can pass next time. So system will generate the same data, and then we are just rendering this one to render get render, and then we are using render.explorer to view this data. Same way we are using with the CSV. In this case, we are getting the data retrieving directly from the repository by using Python data frame pandas, uh, and we are just passing the data frame. So that's it. Thank you for watching.